Pinacol rearrangement. Compounds containing hydroxyl groups on two adjacent carbon atoms are called as vicinal diols, or alternatively called as glycols. Glycols can be synthesized by a wide variety of methods, including oxidation of alkenes by osmium tetroxide. The most important thing that you have to note down here is when the alcohols undergoes acid catalyzed dehydration, it leads to the formation of an alkene. Whereas when a glycol undergoes dehydration, acid catalyzed dehydration, it's going to lead to the formation of a ketone. A pinacol is actually converted into a pinacolone. So this is a ketone because it's ending with -one. Remember, this pinacol rearrangement is specific for glycols. Now let's look into the mechanism for this reaction. The Pinacol rearrangement involves a 1,2-methyl shift. The very first step that happens here is the protonation of one of the hydroxyl groups. I'm going to separate the H2SO4 as HSO3H. HOSO3H. Okay. The first thing, the electrons from the oxygen is going to go grab this proton and it's going to be protonated, thereby converting it into a good leaving group. Once it is converted into a good leaving group, the leaving group is going to leave. Remember, this is very harsh condition, and therefore a carbocation is going to be created. Once the carbocation is created, we also need to find out whether there is whether there could be any 1,2-methyl shift that could be happening. Yes, there is an adjacent methyl group on one of the carbons, and therefore this methyl group is going to shift to the neighboring position. When that happens, a new carbocation is produced, and the other carbon has 3 methyl groups on it. Okay. Now the next step here is the oxygen lone pair of electrons is going to push towards to form the carbon-oxygen double bond. Now, it is the oxygen which is going to have a positive charge. Since it has 3 bonds on it. Now, the last step is the base is going to go abstract this hydrogen and neutralize this positive charge to give our ketone.